Hello everyone, welcome to ClassFly lectures. Coming to surface integral, double integral S f of xy dot n cap ds. Here this is the z axis, okay, this is the y axis and this is the x axis. Consider a vector field, a surface over this region, okay. This is the surface and we have to integrate this thing. So the geometrical representation is we are projecting this area into the xy plane, okay. This is the surface and this is the vector field, and here ds will be dy dz I cap plus dz dx j cap plus dx dy k cap, but here these things will get 0 and the final thing will be dx dy k cap. Here we will have the limits for x from a to b and for y from c to d. That is, we have 2 degrees of freedom with 3 variables changing. Since the curve on the vector field was like this, right? Here both x, y and z, all the three variables are changing. The two forms are integral, double integral S f dot n ds. Here the ds is given as this one and n cap is the unit normal vector to the surface. Since these two get 0, we get ds is equal to dx dy divided by n cap k cap, okay. And the second representation is double integral over S f of x y z ds. Here we take the n cap, here we don't need to n cap c. Here we don't need to take n cap since we have included both the f of x, y, z. The surface integral is also called flux integral since this represents the amount of fluid flow through the surface, and fluid flow through the surface per second gives flux. Therefore, we call the surface integral as flux integral. Moving on to volume integral, triple integral v f dv. We have triple integral v f dot dx dy dz. Here we will have 3 degrees of freedom and 3 variables, okay. In the surface integral we have only 2 variables and therefore we have only double integral. In this case we have 3 variables and therefore triple integral. Consider this example. Here this is a shape. We have the curve y equals x square. Consider a small thickness area, dy thickness, and the radius is ranging from x ranges from 0 to r. Here x equal to 0 and x equal to r. In y axis y equal to 0 and y equal to y at this point. That is dv, since area of dy equals pi into r square. Here r is x, okay. Therefore dv equal to a into dy, which is pi r square dy, which is pi x square dy. dv equal to pi x square dy, and x varies from 0 to r. And we know v is the sum of all dv. There are infinite numbers of dy thickness area in this. Therefore v equal to integral dv, which is integral pi x square dy, and we have the limits over y, 0 to y, and the integration over dy, but the variable is still in x. Therefore we have to substitute y equal to x square. Substituting this gives pi integral y dy. We have 0 to y limit. After integration, pi y square divided by 2, limit 0 to y, which is pi y square divided by 2. Apart from line integral and surface integral, volume integral have 3 integrals. That is, this is a triple integral. For more videos, visit classfly.in.